this? 20 miles per what? Per hour. Okay. What does that even mean? 20 miles per hour. Every hour you travel, you're going 20 miles. That's what it means. And then time would be like, I traveled for, let's say 3 hours. So 20 miles per hour times, right? 3 hours. What's the answer? What happened to the hours, by the way? They do cancel because it's 3 hours over what? 1. It's just a number, 3 hours over 1. Hours and hours cancel, you get what? Miles. Okay? So is it really easy to get the distance? Yep, I got kids going, I got some of you doing this and some of you staring at me. Quit staring at me. Give me this. Yep, or give me this. I don't get it. Okay? Thank you. Thank you, Chris. You're very obvious when you do that. Okay. All right. If you rode your bicycle 12 miles per hour, how far can you travel after biking for 3 hours? Show me the work. Show me the work. I know you know the answer. Just show me the work. Here's your formula right here. Okay, so how far did you travel? Well, you're looking for distance, aren't you? So distance equals rate. What's my rate, Chanel? 12 miles per hour, right. So go like this and this. Multiply it by the time you travel. How long did you travel? 3 what? Hours, okay. I tried to show you up here that hours will what? Cancel out. So you get 12 miles times 3. The answer is what?
36.
36 what? Miles. No, not per hour. Don't say per hour. It's just 36 miles. The question is the distance. You traveled how far? 36 miles. What about if I change the hours and I go to 2 3/4 hours? What if I say 30 minutes? And what if I say X hours? Okay, what if I do that? Give me the answers for all 3 of these. You're going to ride your bike, same speed, 12 miles per hour. It's just I changed the time on you again and again and again. Please use your calculator. I'm not asking you to do this in your head.
I don't know what does it mean?
Should say at the top.
She saw me in the hall.
Probably the end of it. Okay, Chris, 2 3/4 hours. What was the answer?
33 miles.
33 miles, he says. Okay. Okay, he's right, and pretty much all you have to do is this. 12 miles per what? Hour times. Chris, how did you type that in your calculator?
2.75.
Okay, so Chris changed it over to decimals, and he said this. And then he took that times that and got that. Okay? Dallas, after 30 minutes, how far did you travel?
About 6 miles.
He says 6 miles. Okay, so he says the answer is 6 miles. But how did he know that? He took his speed, his rate, 12 miles per hour. He took it times, what'd you take it times?
12 times.
So you did not use the 30. You changed minutes into what? He changed it to hours. So he went back to hours. Why would he do that? Because he wants the hours to do what? Cancel. If he would have put in 30 minutes here, guys, minutes and hours don't cancel out. So he's got to change 30 minutes over to hours. Now what's this? 6 miles. Okay, he got it. What if you say you've traveled for how many hours?
80.
X hours. No, I'm saying X. Okay, so Gabe, what's the answer?
Go on, X.
If I've traveled for X hours, how far have I traveled?
12.
Okay, wait a second. It's you're traveling at this speed, 12 miles per what? Hour. That's your rate. That's R. Times your time. How many hours did you travel, guys?
12.
You traveled X hours. Okay. Now, look at the hours. What are they going to do?
Cancel out.
Cancel out. So all this really says to you is this number 12 times this number, X. What's the answer? 12X. And what's the unit? Miles. So in other words, you really can't tell me how far you've traveled until I tell you what.
The miles.
I got to tell you how many hours you were traveling. So you guys, if I say X hours, you just say my speed times X would be how far I traveled. That's all you have to say. So what if I would have said this? What if I would have said not X? What if I just said Y? Y hours. 12Y. I mean, it's not going to change, right? Y is a variable. I can use any variable I want. I typically use X, okay? All right, read that, look at your formula, solve for the missing part. Go. I shouldn't have to do it. You guys should be able to do that yourself. Something's missing in that formula.
Oh, we have to.
Is that kilometers per hour?
Yes, it is.
That's stupid.
Should say km per hour.
Why don't we just have it in miles?
Whatever. You can do the miles. If you want miles, put miles.
Yeah, but then you have to convert it.
No, just,
Use the numbers.
I don't really care. I just throw in different units at you. I boxed in the how long. When somebody says how long, which one are we looking for?
Time.
Time. How long? How long? I don't know the time. Will it take you to ride your bike 30 kilometers? At what speed? 18 kilometers per hour. So to me, the distance you're going to travel is what? 30 kilometers goes here. The speed you're traveling at, that's your rate, that goes here. So the equation would be 30 kilometers equals 18 what? Kilometers per what? Per hour. Times what? Whatever this is. You can call that T for time. You can call it X. It doesn't matter. And you might want to say X equals the, not times. I don't know why I put times. Just time. Okay? Now, how do you solve it? It's a really simple equation. How do we solve for X? Divide by what? 18 what?
Kilometers.
Per hour. Look at the units, kilometer per hour, kilometer per hour. Guess what? Those cancel. 18 cancels. What do you get? You get X. On the other side, 30 kilometers divided by what? 18 kilometers per what? Hour. Well, the kilometers are going to go away. Your unit will be what? Hours. 1 point what, Brady?
1.6.
Just 1.6? Isn't it 1.66666? Does it repeat? So it's 1.6 repeating hours. You know what? There's another, you could have said it in mixed number. 1 hour and 2/3, right? Hours. 1 2/3 is the same as this, right? Okay. Did I hear you say 40 minutes? Yeah. You know what Dallas is doing? He's saying 2/3 of an hour is actually 1 hour and 40 minutes. So Dallas, that's another way to say it. Most students probably won't say it that way, but That's good. That's good. That's good. They're all good. Yeah? Your thumbs up okay? All right. Good, good, good. Move down. Now it's going to get a little more difficult on you. Okay? And I'm going to give you a secret. Here's my secret. First of all, you got to remember this. Distance always equals what? Rate times time. This is your formula you always work with. Okay, here's my secret. Will you draw yourself a picture of this story? So always draw a picture. And I want you to do this. Use arrows. Use arrows, meaning when you listen to the story, draw an arrow, and I want to know what you drew. Okay? I'll give you 1 minute to read it and another couple seconds to draw a picture. No, it's not draw a picture, it's draw arrows. Just draw arrows. Which way are you going? That's all I care about.
Not very easy.
Lane. Okay. I'll read it to you, and then I'm going to give you the pen. Here you go.
Me?
Wait.
Me, I don't care who me is. You, I'm going to read to you, ready? You and your friend bike what?
Opposite directions.
Hey guys, it's arrows I'm asking you to draw. Opposite direction starting at the same time from your house. That alone should tell you how to draw the picture. Who wants? Who wants to draw the picture? Claire, go ahead. Did you draw this picture that Claire drew? I want to know. I mean, maybe she does it right, maybe she does it wrong. I don't know.
Do you want me to label it too?
You can do whatever you want, and then I'll talk to you.
Sure.
Really the rookie gas.
I don't know if that's your key though.
Yeah.
It's probably.
No, I'm not.
Chocolate. He's like, oh, okay.
Do you need a hug?
You want me to like solve it?
No, you're good. You're good. That's perfect. Okay. Look up. I like what she drew. You know what I did last hour? I put an H for the dot here, H for the house. She actually drew you a house. Okay, no, it's okay. Then she says, she draws an arrow this way, and she draws an arrow this way because you're going where? Opposite direction, so she got that right. Okay, then she says, one of you, is this you, or is this your friend?
That's you.
That's you because you are going what?
Faster.
10 miles per hour. Your friend is going what? 8 miles per hour. Okay, so you drew that, right, guys? Now, this is perfect. Now keep reading. How far apart?
5 miles.
That's the question. How far apart are the two of you after how many hours? 2.5 hours if you bike at 10 and your friend bikes at 8. Okay, well listen to this. Please do this every time you draw a picture. Go like this.
It's not 5.
From here to here, that's a distance. Guys, you travel the distance. Let's call it D1. Your friend goes this far. Let's call it what? D2. Okay? So to me, to get how far apart you two are, how far apart are you? Well, wouldn't it be this distance, D1? Plus, you said, right? Plus what? This distance, D2. So wouldn't that be the answer? If I knew the distance, I just add the other distance and I get the answer. Okay, here comes the question. How far did you travel? Well, you know it's rate times time. Well, Claire, she's so nice to me. She puts the rate down. She did not put the time down. How long have you traveled? Oh, look at this, 2.5. Guess what? you would get what distance?
25.
25 miles. So you traveled 25 miles this way. Your friend traveled at what speed? 8 miles per hour. How long? 2.5. That's what, guys? 20? Oh. So basically distance 1 is what? D1 is how far? 25 miles. D2 is what? 20 miles. So the two of you are how far apart? 40? 5. Yeah, 45. Okay. You're 45 apart. Okay, that was not too bad, was it? Wasn't it? You okay? Hey, did the arrows help? Visually, I think it helps you. Now, do you have to do that? I would say 90% of you should do it. 10% of you might get away with not doing it. I don't recommend not doing it. Okay. All right. Draw a picture. Hey, 2 dogs. You and your friend went this way. These 2 dogs are not going to go opposite. Just read it and draw a picture. You don't know? Read it. Draw a picture. Draw a picture. Alex, draw a picture.
I don't need to.
Show me the answer. So when is the one dog half a mile ahead of the other dog? I would say I think you should draw the picture. Okay. The picture, the picture tells the story. Ready? 2 dogs race from the same location, same spot, and travel the same direction at average speeds of 12 miles per hour and 20 miles per hour. Okay, so here we go. Draw it. Somebody go draw it. Somebody go draw it. Jasmine, you want to draw it?
No.
No? Taylor, you want to draw it?
No, I'm not smart.
You don't have
Alec,
to draw.
Alec, you want to draw it? You think you got it? No. Chloe.
No, you got this.
And I get extra credit.
Oh, you're bad today.
I got it.
You got it? Come on, do it. Just draw me a picture. Maybe it's right, maybe it's wrong. We don't care. We will look at it and see what he does. Same location, same direction.
Doghouse.
Doghouse. He starts him at the doghouse.
That's a good idea.
No.
Alright.
Buddy, could you laugh at this?
And they both go this way.
Okay. Both in the same direction. There's 2 dogs, so draw 2 arrows.
I'll show you the other one.
Hey, what class?
Good. All right, I'll take it. There we go. All right. He drew 2 arrows for 2 dogs. Call it dog 1, and dog
I'll be
2. Okay.
or yeah.
Taylor. 2 dogs raced from the same location. Hey, is this the same location? Yep. Okay, same spot. Go. Okay, 1 dog travels at what speed?
Wow.
12.5 miles per hour. The other one travels at what speed? 20. Okay. How much time elapsed before the 2 dogs are half a mile apart? Okay, here's the deal. So 1 dog takes off running. Kind of slow. He's a little overweight. And then there's another greyhound. He takes off. So 1 dog is going to go faster. 1 dog is going to go slower. Would this be what they look like in the end? Are they equal? No. 1 dog is slower. Here's the slow dog. So really, I think this should have been more what? Like here. Right? And then fast dog is here. Because he's going fast. All right. What's the speed of this dog? Isn't this one 12 miles per hour? Okay, this dog's going what? 20 miles per what? Hour. Okay, so the two arrows are not equal. But we can make them equal. Look. See this? Right there? If I go like this and this, are they equal now?
Yes.
Yes. Do I know this distance?
You should.
What is it, Alex?
8 miles.
This from here to here? Why did you say 0.5? Yeah. How much time goes by before the two dogs are what? Half a mile apart. From there to there, guys, this slow dog is a half a mile behind the fast dog. Or the fast dog is half a mile ahead of the slow dog, whatever. Now, would you guys look at those two arrows and tell me, are they equal distance? Look, see this? See this? Are they equal? Yes. So the two distances are equal. So you know what I would do? I would set my equation up like this. I would call this distance, let's call this one D2. Let's call this one, from here to here, let's call this D1. Okay, sorry, I didn't read this. Okay, now, what would the answer be, the equation? This distance, D2, should equal this distance. How far is it from here to here? Okay, how far from here to here? What is this? No. I called it D1, didn't I? It's D1 plus, how much more? 0.5. There you go. Yeah? Okay. Well, here's the problem. What's your distance? How far did the dogs travel? You ready? We got to figure this out. This dog is traveling at 12 miles per hour. And for how long did the dog travel at that speed? Did it ever tell you how long the dog ran?
$8.
Nope, never told you. So then what should you say? Well, that's what you have to figure out. So if you got to figure that out, we probably better say time the dogs ran. Okay, well here's the deal. Did the dogs run the same amount of time? Here we go. Both dogs ready? We're sitting here. Ready? Set, go! And we start running, both dogs. Both dogs are running. Both dogs are running. When does that dog get half a mile ahead of this dog? Guess what? That's the same amount of time. That dog's just faster. So X will be the same for both dogs. So this amount of time this dog ran was what? 12 times X. What is it?
12X.
12X. That's the distance. Okay, what about this dog? 20 miles an hour times what time? Same time. They ran the same amount of time.
Ouch.
So it's 20X. Okay, 20X. Okay, ready? Put the numbers in. What's D2? What's the distance from here to here? Well, it's not X, it's 20X. Okay, what's the distance from here to here, guys? Right here. This to here. 12X. Oh, wait a minute. But I got to add another what? Half a mile to get it equal to the fast dog. So add 0.5. That is the hardest part of this problem. You know what? I gave you this problem like 2 weeks ago. I said solve it. Well, now solve it. It should take you about 20 seconds.
You know why?
Move the X terms on the same side. 8X equals what? 0.5. Divide by what? 8. I don't know. What is it? 0.062. Is it 5? Yeah. Now, that is it measured in what? Minutes? Seconds? Hours? What? Look. Hours. Right there, guys. The time is given to you. Hours. So we will say what? 0.0625 what? Hours. So how long did the dogs run before one dog got a half mile ahead? Not very long. Very, very little tiny bit of an hour. Now, you know what that is. How long is that?
6 minutes
6 minutes
and 25 seconds.
and 25 seconds. He is wrong. But you are sort of close, Chris. Sort of.
6 hours.
No. That is not even 1 hour. Guess what, guys? We got to convert this to minutes so we know how long the dogs ran. What is it? What is it, Dallas? Yeah. 3 minutes what? 3.75 minutes. Okay, here's what he did. He went like this. He knows he has this many hours, right? He has this many hours. He wants to get rid of hours. You learned this in science class. Multiply by the conversion rate. You want hours to cancel with hours, right? And you want minutes. Okay, what's the conversion rate here, guys? Anybody know minutes now? 1 hour for every what? 60 minutes. Multiply, what do you get? Hours are out. Dallas, you kind of told me, I think you said 3.75 minutes. Okay? So guys, the dogs ran for just about 4 minutes, and one dog is half a mile ahead of the other dog. Okay? Now, if you would have given me this answer on the test, would I count that wrong? No, that's right. It's just that you don't even know what that number is. So I wanted to make it into something you do. You know that. That is hard to understand. Okay? All right. We got one problem left, and I need you to cross this out. Right here, right here, right here, right here, right here. Oh, get rid of that. Okay, cross out the 150. Now, would you just draw a picture of this story? Get the picture on paper. Two dogs, you and your friend. Now we're what? 2 cars. It's always the same. 2 of something. 2 cars. Students are traveling in 2 cars to a football game. Okay, got a picture in your head?
Yeah.
2 cars. Okay. The first car leaves on time and travels at an average speed of 48 miles per hour. So it just basically takes off and goes 48. Second car starts a half hour later and travels at an average speed of what? 58 miles per hour. Okay, so the question down here says, at these speeds, how long will it take the second car to what? Oh, that's a big one right here. Look, see that? It's got to catch up. So when you draw the pictures, the second car has to catch up to the first car, right? So can I do this? Here's car 1. Here's car 2. Here we go. Here we go. Okay, you ready? Car 1, that's you. You taking off on time, and you're going down the highway at what speed?
48.
There you go, 48. You're very safe. You're very safe. Gotta get to the football game. Take my time, take my time, take my time. Boom, boom. Okay. Now, this guy, car 2, that might be you. You're sitting there eating your McDonald's, you're having your Big Mac, you got your fries, you got your Coke, you take it, you throw it away, you take off half hour later. So you don't take off on time. You're a half hour behind this guy. But you take off. And you take off at a faster speed so that you can do what? Catch up. So when do I catch up? Tell me when to stop.
Now.
Jeez, you guys are bad.
You kept on going.
So do you think, hey, look at the distances. Are they equal?
No.
No. You caught up. To me, this distance and this distance, D1 and D2, they're equal. Okay, so distance 1, distance 2. D1 should equal what?
Rated.
Were you looking? D1 should equal what? D2. Okay. So, all you really have to figure out is how far did this guy travel and how far did this guy travel? You know the speed, don't you? What did this guy do? 48 miles per hour times
Monkey gas.
how long did this person travel? This person traveled at 58 miles per hour,
So,
right? But how long did this guy travel? Now this is where it gets kind of tricky. Did they ever tell you how many hours they traveled? No. So one of them's got to be X. Which one do you want to be X? It doesn't matter. You want the what? Okay. Is everybody okay? Chloe said let the X go with the fast one. It doesn't matter. Would you guys tell me which one you want? She wants 58. You okay with that?
Slow car.
Who wants slow? Okay. X equals time of what?
Departure.
Slow car. Okay? So that's here. Got it? Now tell me something about the fast car. How long did it travel?
58.
Should I put X? Wait a second. You guys, you're in the fast car. Did you travel the same time as the slow car?
No.
You took off a half hour later. So your number here would be bigger than that or smaller than that?
Bigger.
So Chris, if this was 3
Smaller.
hours,
I meant smaller.
yeah, because you've been on the road less time. How much less? Half an hour. Oh, half an hour. So guys, if that was 3, guess what this one would be?
1/2.
2.5, right? Okay. All right. Set them equal to each other. Let's go. Let's do it. 48x, right? Equals 58x minus a half. There you go. Solve it. See what you get. Do it, do it, do it. Hopefully this doesn't take you long, because this is back to section 2.1. Use your distribution skills, right? What's the answer for X?
2.9.
2.9. Okay, let me see. So I move this over here, right, guys? So minus 48x, minus 48x, and I get 10x minus 29 equals what? What's this? 0. Okay, now what do you do? Probably add 29. Add 29. 29 equals 10x. Divide by 10, you get what?
Oh, okay.
What do you get? Oh, Chris, you said what? 2 point what?
2.9.
9. Okay. And since we're dealing with miles per hour, this is measured in what? Hours. So, how long, let me ask you this again. How long, stop. Okay, come back. Okay. At these speeds, how long will it take the second car to catch up to the first car? Well, X is what? 2.9 hours. But that's not true, because the second car traveled a half hour less than the first car. So the second car traveled at what speed? Or how long? I'm sorry. Put that there. So the second car only took what? Put the 2.9 here. Take off a half an hour. Second car traveled how long? Oh, you're not speaking. If you put the 2.9 in and you take off a 0.5, 2.4 hours, yes. Okay. That is how long the second car traveled. Because it said this, didn't it? At these speeds, how long did it take the second car to catch up to the first car? Took 2.5 hours. Or sorry, 2.4 hours. Now, if you would have got 2.9 and you said the answer was 2.9, I would have probably given you